there. All right, so we see that we're in the RStudio environment, and I'm going to walk through with you guys how to run and conduct several different types of plots using the RStudio software. But first things first, we first have to import our data set, and we do that by clicking Import Dataset. And my data set was saved as a CV file or CSV file, so I'm going to click that. Then we see we have a Browse button here. I'm going to click Browse, and I know that my data set was saved to my desktop, so I'll locate my data set and see that it was saved as Salaries 2. I'm going to select that and then click Open. And we see that we have a data preview here, so this is what our data looks like in our CSV file, and this is the data set that we want, so I'm going to go ahead and import that. And we see now that R has recognized that the data set Salaries 2 exists. So now I'm going to go back to our script file here, and we see that our first command is a library command, and we have a library command with an read Excel function or package in this case. And what a library command does is allows us to open these types of packages in order to perform different functions and different commands, read different files in RStudio. So what I'm going to go ahead and do is run these. Run, okay. And so R has recognized our data set, but in order for us to actually use our data set, we first have to use the attach function or attach command here. And what the attach command does is it equips our data set so that we can use it in our software or in RStudio software. And so, for example, if I had different data sets that I imported earlier with different tabs up here, I could then select which data set that I wanted to use by indicating it here. And I would run that command and it would attach that particular file. At line 3, we see that instead of, we see this, we see the earlier data set, Salaries 2, with this arrow symbol here, which we call a push command, and which is pointing toward test data. And so all this data set, or all this label does, is allows us to rename the data set Salaries 2, rename that data set test data. So when I ran that, we saw that we had Salaries 2 data set before with our 397 observations of 7 variables. And the only thing that's changed after running that particular command is the name of the data set. So in this case, test data. And we still have our 397 observations of 7 variables, and we can see that here in the preview. In this case, with the data set, we're looking at the different salaries of professors in a college in the US. We have some information about their particular rank as a professor, and by rank I mean whether or not they're an assistant, an associate, a professor, or a full professor. And then we have some information about their discipline, the years since they had received their PhD, the years of service in academia, and whether or not they are males or females. So we've recognized our data, or we've opened our package, we've recognized our data, and we've equipped our data, and we've indicated that we want to use the dataset name test data as so. So now we're ready to plot our first plot. And this first plot at line 5 is a scatter plot. So I'm going to go ahead and run this and show you guys what we're going to be working with. So this first command, we see that we have a plot command. And this plot command tells R that we want to run a scatter plot. And so we see here that we have a scatter plot. and it's a scatter plot of the professor's salary by the years since they received their PhD. So we have salary since PhD, plotted like so. So how do we do that? As I said, we have our plot command, but we're specifying the test data. So we pull down the test data, we indicate it here. Then we see that we have a $, which is basically a specification symbol, and then we see the variable salary. So in other words, what this means is that we have specified that we want to use the test data set and that we want to pull down the variable salary, or use the variable salary. And because we have indicated salary as the first variable, it becomes our x variable. And then we see again, we have test data telling R which data set we're wanting to use, and which variable we want to indicate, followed by the $. And then in this case, the new variable is years since PhD. And since years since PhD is our second variable, it becomes our y variable. Okay? So there we have, and then we have our main function, or main command, and the main command allows us to indicate which script, or the script that we would like to have for the title of our graph. And similarly, we have the xlab command, which allows us to indicate what we would like the title of our x label to be. As just as well with our ylab variable, or ylab command, where we're able to indicate what we would like the y label to be. In this case, it would be, so in this case we have the x label is salary, and the y label is year since PhD. And then we have a PCH equals 24 command. But let's take a look at the scatter plot here. So of course we see we have our title, salary since PhD. We have our y label, which is year since PhD. And then we have salary plotted like so. What the PCH equals 24 command allows us to do is to indicate the type of symbol that we would like to use to represent our representing our data points in our scatter plot. So the PCH equals 24 command, in this case, indicates that we would like our data points to be represented in the form of equilateral triangles. And that is how you plot a scatter plot in RStudio. Our next plot we'll be working with is a density plot. But first we see that the first thing we have to do is open another library command, or run another library command. And again, the library command lets us open packages in RStudio. And the package that we're opening in this case is the SM package. And this package allows us to work with the density command in R. So for example, we have our sm.density.compare command that we're able to work with using this SM package. But let's talk through what each of these commands mean, a little bit more about each of these commands before we actually run them in the dataset or in the software. Okay, so here, line 8, we see that we have a factor command. And a factor command essentially allows you to encode the parameters of a particular variable. So in this case, we've indicated that we want to use the test data set, again, this time specifying rank. And we've indicated that we want the rank, our rank variable, to be represented by the number of levels that we see here with the levels command, which indicates the number of levels, and the C command indicates the values in a particular sequence that we want to indicate as part of this levels command. So in other words, what we're saying here is there are in fact 4 levels to this, 4 value. In this case, there are 4 values in this sequence, and these 4 values are going to be used to represent the number of levels that we have in our data set rank. And then we see that we have a labels command, and this labels command correspondingly tells R that we want to not only that we have 4 levels in our R variable, but that we want to label those 4 levels based on the sequence with the C command: assistant professor, associate professor, professor, and full professor. And we see in that the each label's place in the sequence corresponds to the particular level in which they appear in the sequence, the first sequence for levels, the levels command. So we have labels, the labels command equals our sequence, which is assistant professor as 1, associate professor as 2, professor as 3, and full professor as 4. And what we've done is that we've told R that we want these parameters to be represented by the variable rank.x. And we see that we have a push command that tells R that we want to have all this information in this in line 8 to be represented by the variable rank.x, so that we don't have to keep referring to it and retyping it over and over. We can just simply type or input rank.x as the variable. Okay, so we're ready to run our main command, which is our sm.density.compare command. And we see that we have, again, within this command, we have our test data set that we've indicated, and we've also specified that we want to use the variable salary in this case, so that would be our x variable, and then our second variable that we've indicated using the test data is rank, followed by the money sign here, or the dollar sign rather. Then we see that we have an x label command, which allows us to indicate the script that we want to use to label the x bar in our graph. And then we have on line 10, we have the title command. What the title command does is it allows us to input the main command in order to, so for example, since I didn't put the main command in the first function here, I'm able to insert a title command, which allows me to still run that main command with the graph. So I'm still able to title my data set accordingly. Then we see we have a cold fill variable at line 11, where we have, again, this sequence or C command where we have indicated the number of levels that we have in our previous rank.x variable, which is 4. And then we also have a link command, which is telling R it allows us to set the number of values in our list. So like we have a list here with the command 1, 2, through 4. That link command allows us to set the number of values that we have in that list. Then we have the levels command. In this case, we've already pre-specified the levels command here at line 8. And so at line 11, we're telling R that we want to use the levels that we specified in line 8 based upon the rank.x variable that we indicated before. And then we want all that information to be represented by the variable coalfill. So we see here that we have a push command. So we're taking all this information and replacing it or substituting it with the variable coalfill, right? Okay, so I'm going to go ahead and run some of these commands just to show you what we're working with. Okay, so here we see we have our density plotted. The title of our graph is salary by rank, and we see that our x values are represented by salary or labeled salary. Then we see our 4 density plots by rank. And now we get to this legend function. The legend function tells R that we would like to place a legend in our graph, in this case our density plot. And then we see inside the legend function that we have a locator function. The locator function tells R that it allows R to keep track of the cursor as we are moving over the graph, so that R knows where to place the legend once we've indicated in the graph where we would like it to be. So for example, you see how my cursor goes from an arrow to a crosshair there. So all that means what R is telling me to do is to click anywhere in the graph. I'm going to click here with a left click, and what that has done is placed a locator, or placed the legend where I indicated with the locator function. And then we see that we want levels to be indicated by, or to be based on rank.x. So what we're telling R is that we want the levels of the variable rank, in this case, we want them to be labeled assistant professor, associate professor, professor, and full professor, and which is based on what we indicated in line 8 of our code, right? And then we have a fill command, and this fill command, we have this variable, we've indicated this the coalfill variable, and what we're telling R is that we want to fill in the colors of the legend based on the coalfill variable that we created earlier, which is based on this information that we represented with our length, levels, and rank, right? And we've run that, and shows that we have our 4 colors filled in based on the color of the graph. Okay, so our next command, or next plot rather, is a bar plot. So I'm going to go ahead and run that. And we see the command there we see is a bar plot command. So that what that tells R is that we want to run a bar plot. And then inside that command we see a table command. And the table command tells R that it specifies that we want the information to be represented in a table. And in that table we want to represent the variable rank. And then we see, we've got our main command where we're able to specify the title of our graph, in this case, number of professors by rank. See, number of professors by rank. Then we have our xlab command, which tells our what we would like our label to be for our x value. And then we have our ylab command, which tells R that we want rank to represent our y label in this case. So again, we have number of professors by rank. We have our rank here for our y variable. Then we have our x variable with x variable label with number of professors. But okay, so how did we invert this plot? Because normally a bar plot would be, your x values would be here and your bars would be going this way. But instead of having it represented vertically, we had plot the graph horizontally. And we did that by inputting the command HORIZ, or horizontal equals true. So there we go. And you click the arrow here to go back to each one. Right. And that is how we run a scatter plot, a density plot, and a bar plot in RStudio. Cheers.